All right, now that we have taken a potato and turned it into a sheet of plastic, let's talk about the chemistry behind what is a plastic. What are plastics? Um, so plastics, almost all plastics, with the exception of silicones, are long chain molecules of carbon atoms. Um, why carbon? Why is carbon primarily that atom? Because it's got four valence electrons. It can form bonds on four sides. I can take two carbons and link them. For example, C2H4. I took the two carbons, added two hydrogens. I got these two on the outside. Let me bring them in, make a double bond. That's how we stop it if it's just that, right? However, what if I break that double bond? Let's break it. Put these guys back out here. Now it's almost like if you take someone's arms folded and hold it out, what can happen? They can link now to other C2H4s. If they break that double bond and stay like that, here's one, here's a second one. Let's bring them in, connect, and now they're shared. So now instead of two carbons, I've got four. And then I can keep going and make it and link the carbon, 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 carbon. And these polymers or plastics are these long carbon chains, usually hundreds of carbons long. And they form these long chains like spaghetti. So we call whatever it was, the single thing that we kind of broke up and started connecting, and multiples of them, we call that a monomer. So once we connect all these monomers to this long chain, we call it a polymer. So a slightly more technical name for a plastic is a polymer. Plastics are polymers, these long chain of continuing subsets linked together. So it's just like a chain is made of multiple links, a polymer is made of linked together multiple monomers. So what happens is then these long chains, of course all plastics are solids at room temperature because there's really long molecules and they're scrambled together like spaghetti. And so there's a lot of chance for interaction. So the interaction between molecules is strong enough that of course they're not going to flow apart as liquids or of course become gases. So they're solids. But the plastics are all different in their flexibility. Some are like super flexible like this plastic tubing. Some are a little bit less flexible like this plastic ruler, flexes pretty easy. Some are not flexible at all like this little plastic tool case. So all kinds of different properties, and there's so many ways that we can modify this long chain to give the plastic different properties. There's so many different plastics. Even the tabletops of our classroom are plastic, epoxies. So what can I do to do this? So a flexible plastic has these long chains, but they can kind of slide past if you put some strain on it. The molecules can slide past because they're not really locked together. Two different things I can do to make them less flexible. I can branch them. So if here's my monomer. When I connect it to another monomer, I get this. And then because carbon has that tetrahedral shape, it tends to form this zigzag pattern. And it just continues along, zigzag, zigzag. But I can pop one of these hydrogens off and attach a monomer where the hydrogen was. And now what's happening is, and I can branch from there and keep going, what's happening is this long chain now has a branch coming off on that side, and that branch can of course keep growing and growing and growing. So I'm going to branch this guy, maybe in several different places. These branches can be quite long. But now what do I have? It's kind of like a barbed spaghetti, or kind of an interesting. So now they're not as able to slide past each other. The plastic becomes less flexible because of that branching. So the branched polymers are less flexible than what we call the straight chain polymers. The other thing I can do if I really want to lock it in, I want to be more rigid, is I can do this. Erase my branches. Well, if I don't want them to slide past each other, I want them just to kind of more lock into place. Instead of just, I can make those branches, but I can make the branch like a link. So the branches go in there and tangling, I'm actually locking them together here and there. When I link them and I try and stretch them, they're just not gonna move. So I can link the polymers like this, and so there's so many ways I can change the flexibility. Another thing I can do to change the property of plastic, why does it have to be just carbon and hydrogen? If I could pop off a hydrogen to form a branch, can't I pop off a hydrogen to do like an OH? Sure. What does that do? I put a little polar end on there. That's going to change the properties of the plastic. That might make a plastic that actually would absorb water. Another kind of common, so this one is called polyethylene. If I do this kind of thing, now I've got another type of structure, not just carbons and hydrogens, totally change the properties of the plastic. This one is called polyester. So there's so many ways that chemists can modify these polymers to give them different properties by just changing what's going on with that, either by branching them or by linking them or by changing what's coming off of that carbon chain to put something else in. I can get completely different properties. There's so many different types of plastics because these molecules are so easy to modify. So there's our piece on plastic, and there's just so much more to come on this, and we'll continue to work.